You know, when we look at a towering skyscraper, a beautifully designed home, or even an enormous water reservoir, we naturally marvel at what we can actually see, right? The steel, the glass, the structural concrete. But here's the thing, the survival and stability of literally all those magnificent structures rely on an unsung hero that is quite literally buried in the dirt. Today, we're jumping right into an explainer on a foundational element that is so essential yet so frequently overlooked, it perfectly embodies the phrase out of sight, out of mind.
Think about the floor beneath you right now. Seriously, if you to peel back the carpet, rip up the floorboards, break right through that heavy structural slab, and dig straight into the earth, what's the very first man-made thing you'd hit? Well, I'll give you a hint. It is the absolute most important part of a building that you will never actually look at once the building is finished. It's this incredible, invisible line drawn in the sand between human engineering and unpredictable nature.
Okay, let's dive right into Section 1, the hidden foundation layer.
So let's uncover exactly what this unseen layer actually is. We're talking about the absolute first step in heavy construction, the layer that has to go down before the real building even begins. Now, in the engineering world, this is known as plain cement concrete, or PCC. You can also just call it bed concrete. I like to think of this as the ultimate heavy-duty screen protector for a building. Just like you wouldn't take a $1,000 smartphone and just toss it into a pocket full of sharp keys without a screen protector, you definitely don't take highly engineered, super expensive structural concrete and pour it directly onto raw earth. Bed concrete is this preliminary layer placed right on prepared soil before the main structural work starts. It steps up and takes the initial hit from the environment. It deals with the dirt, the dust, and the dampness, so that the expensive structural core of the building stays completely pristine and mathematically perfect.
To truly appreciate why this matters, we have to starkly contrast raw soil with bed concrete. I mean, raw soil is chaotic. It's muddy, it's totally uneven, it's packed with moisture, and its chemical makeup completely unpredictable. If you pour expensive reinforced concrete directly onto raw, muddy soil, that soil will actually suck the water right out of your concrete mix, totally ruining its strength. Plus, the mud contaminates the clean cement. But bed concrete? It changes the game entirely. By laying it down first, you instantly transform a muddy, unpredictable pit into a clean, hard, perfectly level, and incredibly stable base. You are essentially creating a sterile operating table on which the rest of the building can be safely constructed.
And this perfectly illustrates the sheer efficiency of human engineering. We're talking 75 to 100 millimeters. That is just 3 to 4 inches. It's a classic small but mighty scenario. We are talking about a layer of concrete that's scarcely thicker than the width of your hand. Yet this thin, unassuming barrier is literally all it takes to hold back the destructive, chaotic forces of the earth and moisture. 3 to 4 inches. That is the literal difference between a foundation that lasts a century and one that cracks and fails within a decade.
Let's move to Section 2 and look at 3 vital applications for this.
So let's see how this builds into the practical reality of a construction site. This unsung hero, it isn't just a one-trick pony. It actually has several critical roles, depending on what's being built on top of it. What's really interesting here is how the common thickness, that magic 75 to 100 millimeters, remains completely constant across footings, water tanks, and flooring. But the typical grade, the concrete mix ratio, that shifts depending on the specific protective role the bed concrete is playing. A standard footing might only need an M7.5 grade. But a water tank, which is dealing with intense moisture and pressure, well, that requires a stronger M10 or M15 mix. Let's break each of these down.
First up, we have footings. In construction, footings are those heavy, reinforced concrete blocks that carry the massive weight of the columns. The bed concrete is laid right before this reinforced structural concrete, or RCC, is poured. And this does 2 massive things. First, it gives the workers a firm, geometrically perfect surface to set up their shuttering and lay down their steel reinforcement bars. Second, and honestly most importantly, it prevents the vital cement slurry of the structural concrete from mixing with the raw soil below. If that slurry bleeds into the dirt, your main foundation loses its structural integrity. The bed concrete stops that dead in its tracks.
Next up, we have heavy-duty water tanks. Here, the bed concrete is placed directly below the massive base slab of the tank. Just think for a second about the incredible weight of thousands of gallons of water, right? If the ground settles unevenly under all that weight, the tank cracks. The bed concrete creates a perfectly smooth foundation that reduces that uneven settlement. Plus, it acts as a crucial line of defense against ground moisture seeping up and rusting out the steel reinforcement hidden inside the tank's base, which, trust me, is an absolute nightmare scenario for waterproofing.
Finally, let's look at flooring. This is the application that is literally closest to home.
Every single time you walk on a beautifully tiled floor or a polished screed finish on a ground level, you actually have bed concrete to thank. Used directly below these finishes, it acts as the vital base that evenly distributes the load of walls, furniture, and people across the earth below. It also works as a moisture barrier. It significantly reduces the amount of dampness that can penetrate up from the ground, which keeps our indoor spaces dry, healthy, and structurally sound.
Which brings us to Section 3, the core benefits.
So the crucial point here is that while the application might change slightly, the fundamental purpose remains exactly the same. Let's quickly run through these benefits, because together they tell an incredible story. This 4-inch layer provides a clean and level working surface out of literal mud. It totally prevents the contamination of your expensive structural concrete. It improves load distribution so heavy weights don't just crack the floor. It reduces differential settlement, meaning the building won't sink lopsidedly into the earth. It massively enhances the long-term durability and service life of the entire structure. And ultimately, it acts as the baseline for accurate construction and much better finishing. Look, these aren't just dry technical specs. Combined, they form an invisible shield that absolutely guarantees the survival of the building above.
And finally, Section 4, why this layer matters.
Understanding this hidden 4-inch layer genuinely changes how we view the structures we live in, the offices we work in, and the infrastructure we rely on every single day. A quote directly from our source material synthesizes this perfectly. It says, "Bed concrete is an essential preliminary layer. It improves stability, durability, and the overall quality of the structure by providing a strong, clean, and level foundation. It is quite literally the foundation of the foundation." It's a true testament to the idea that the most critical work is often the work that receives zero glory. It does all the dirty work so the rest of the building can shine.
And that leaves us with a truly fascinating thought to ponder. If just 4 inches of plain concrete is the secret to securing a massive, towering structure against the chaotic forces of nature, what other hidden foundations in our world are we completely taking for granted? What other invisible systems are working silently right beneath our feet to keep our modern world standing? Keep asking questions, keep looking beneath the surface, and hey, thank you so much for joining me for this explainer.